Here we are talking of buoyancy in sand casting. So before we read below, just a quick background. If you remember your basic physics and so on, the Archimedes principle, right? Then you remember buoyancy, that if there is a solid body which is floating in liquid, like there is a ship or a boat in water, and some part of it is under the water, the rest of it is above the water. So what will be the buoyancy force? What will be the force that the liquid pushes up on the boat, and it is exactly balanced so that it is floating, right? Because otherwise the heavy body will sink into the water, right? So buoyancy was there, and if you remember, it is equal to the weight of the displaced liquid. So now this is buoyancy whenever there is some solid object which is floating in liquid or fluid. Now in casting, why is it important? So in casting, buoyancy is important only when there is a hollow casting and you have a core inside there. If you remember, right, that there is a mold cavity and the liquid metal will go and fill out the whole mold cavity. But if it is to be a hollow casting, then you will fit a core. You will fit a core in the middle somewhere of the mold cavity. So this solid core will be floating inside liquid metal. So therefore buoyancy comes into consideration. So let us read and see. During pouring, buoyancy of the molten metal tends to displace the core, which can cause the casting to be defective, right? The core needs to be exactly in its place. The core needs to be exactly in its place. If the core is not in its place, then the hole is in a wrong location. So the buoyancy of the molten metal tries to force or displace the core from its original position. Therefore, calculating the buoyancy force is important, that will the weight of the core exactly balance it or not, right? So force tending to lift the core, the buoyancy force, is the weight of the displaced liquid less the weight of the core itself. This less means minus. So this is the equation, very simple. FB is equal to Wm minus Wc. FB is the buoyancy force. Wm is the weight of the molten metal displaced. Molten metal, how much molten metal has been displaced? Equal to the volume of the core, right? Equal to the volume of the core, but using the density of the molten metal. And Wc is the weight of the core itself. So again, what volume? The core volume, but this time the density of the core material, right? So it's a very simple thing. If this equation is not written, then maybe it will be a little tough to find out what it is, but this is simple. Weight of the metal. Weight of the metal means take the core volume of the core, and use the density. You know that, you see, density is mass per unit volume and so on, right? So you find the mass, because the volume is the core volume multiplied by density of the metal, you get the mass of the metal, and right, and then the weight is just mass into G. Similarly, weight of the core, the volume of the core is directly there, you need the density of the core. So to find the buoyancy, you need the density of the molten metal and the density of the core, and this is it, right? So now that you know it, it's a very simple calculation to do. If it was not explained like this, then it might be a little more complicated for you about how to calculate the buoyancy that is acting on the core inside the mold cavity. Okay, good.